We're going to take a look at the catastrophic impact that caused the extinction of the dinosaurs here on Google Earth. So here are the coordinates of the actual center of the impact. Okay, so this is commonly known as the Cretaceous-Paleogene extinction event, or the KPG event. A large asteroid crashed here 65 to 66 million years ago, which marked the end of the Mesozoic era and the start of the Cenozoic era, which continues today. The event resulted in what's known as the Chicxulub, if I'm pronouncing that right, Chicxulub crater, which is here in the Gulf of Mexico, Yucatan Peninsula. So just to give you an idea of where that is exactly, continental United States, Central America, and it's right here in this peninsula, just off the shoreline, which is the center of the impact. Now, the crater itself, or sorry, the asteroid itself was 10 to 15 kilometers in diameter, but the size of the crater was much larger. Close to, well, they anticipate, they estimate 150 to 180 kilometers in diameter. So just to give you an idea, I'm going to put, we'll say a 90 kilometer radius, which would mean a 180 kilometer diameter, about there. So this gives you an idea of the actual size of the crater. It's a very significant impact, as we know. The asteroid came in, they found out that it came in roughly from the northeast, so coming up here, and it crashed down here at about a 45 to 60 degree angle from the horizon. So fairly steep, devastating impact. The crater itself, being 180 kilometers in diameter, is about 20 kilometers deep at its deepest point. So a very powerful impact. Blast, they say, is about 1 billion times larger than that as far as energy goes, as the impact at Hiroshima and Nagasaki, the atomic bombings that at the end of World War II. So just a devastating, catastrophic event. What would have happened here, let's close that out, is the crater would have landed, or sorry, the asteroid would have landed and caused a massive ejection of rock and soot into the atmosphere. Much of that rock would have been under such heat and pressure that it would have vaporized and gone right into the atmosphere, completely covering the entire Earth. That global soot cloud would have blocked sunlight completely. They expect it to be probably fully in complete darkness across the Earth for about a year, followed by 3 years of permanently frozen temperatures. This is called, it's known as an impact winter event. So that would have resulted in a halt of the photosynthesis, rapidly reduced global temperatures, ecological collapse, devastating the food chain. Just go over here. Here's a pretty interesting rendition of what the crater would have looked like. So you get an idea of the impact. Here's the Yucatan Peninsula that we were just looking at. It was right off the shoreline, or where the current shoreline is, and that's the size of the crater. And actually, if we go back here, you can see remnants to this day. So if you follow my cursor right around here It's tough to make out, but you can definitely see an elevation difference, and it even kind of goes up in this area. And the center of that radius is right here at the epicenter of the impact. So you can see the remnants to this day. This is a better picture that shows the ring that I was just referring to. So you can see there with the Chicxulub impact about right here. Here are some of the other impacts on the Earth that we've endured. Here's the one that we're talking about, the Chicxulub. You can see diameter, it's saying 150 kilometers, about 65 million years ago. This is the second largest one that known impact that we have evidence for. The largest being over here, the Vredefort impact, which was 2 billion years ago, much longer ago than this one. Back. So when this asteroid hit, there would have been rock containing hydrocarbons and sulfur and other elements that were vaporized and ejected into the atmosphere, like I mentioned, and that would have eventually rained back down as sulfuric acid rain. That rain would have acidified the oceans, caused fires, high amounts of carbon dioxide, the greenhouse effect. So you can see that there's a gigantic ecological devastation that occurred as a result of this. They anticipate 75% or more of the Earth's species became extinct, not just dinosaurs, but a myriad of plants, fish, mammals, other terrestrial organisms. So this was clearly a earth-shattering event, and there are still signs of remnants of this across the globe to this day. It's called the KPG boundary, and it's a thin layer of sediment. Just maybe a photo here. So this photo is actually in Drumheller, Alberta, in Canada. There's a line right around here, and that line is the KPG boundary, which is the soot sediment that would have fallen down as a result of the asteroid impact. The reason they know this layer of sediment actually contains very high levels of an element called iridium. Iridium is very rare on the Earth's crust. It's such a heavy element that at the birth of the planet, that element almost fully went down into the center of the core and is there today. So on the Earth's crust, there's very trace elements, amounts of iridium. But this amount here is significantly 100 times higher, and the iridium is abundant in asteroids. So that's how we know that this was part of that event. So there you have it. That's the major extinction event causing extinction of the dinosaurs.